going through what we've actually been doing with the dispatcher in Lava. It grew organically and it stopped growing. So we've had to go for a rebuild, a restart, and we're building up from the base. So we're trying to look at what we're actually going to gain from the new dispatcher. Much better error identification and cleanup after errors. So we'll be able to identify these things, we'll be able to spot things easier, fail earlier, give you more information, give you more help as it actually goes along. Equally, then a retry, diagnostic actions are things that say, well, okay, something didn't look right there, let's report on the output of a particular command. Just say, what's the ifconfig information, what's that particular, why isn't that filed out to a file list, just put things like that. And conditional repeats as well as retries on failure. We're doing this as a pipeline. We're doing it by generating the actions in advance. We're building the entire pipeline of the job before we do the validation. So we've got everything in place, and we stick with that pipeline right through the job. Each job has its own pipeline with its own set of actions. And we're keeping the actions out important so that we can be sure that these things will look after themselves and they're self-contained units as they all go through. Now, the old dispatcher does a lot of processing on the device to say, well, okay, I've done what you've told me to do, now I need to work out what results am I going to give you. And it doesn't give you everything, it just gives you what it thinks you want, which is one of the principles that we're throwing away with the new dispatcher. We're doing less of the guessing, doing less of the assumptions. We say, well, if you tell us you want us to do that, we'll do it. If you don't tell us to do that, we won't. And if the job fails, that's your problem. So the new dispatcher gathers up all the data it was actually asked to in the pipeline. So the pipeline says, I want results for this, 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 this. Each of the actions has an ability to have a result. Everything then gets put back through to the job. So you don't lose data. You don't have to think, oh, I've got to rerun that test to get more data. The data's there if it was actually in the pipeline in the first place. The logs are going to be more structured. So the log, as it's generated, will be valid YAML, and we'll be able to then do analysis on the log file much more easily. And the logs are self-contained, so that as you're working your way through the actions, the log for that action is one particular file, and you can parse that bit individually. It gives you much easier ways of doing things later on, like folding the logs according to see which bits are interested in, which are not. The whole thing is to get it faster, smaller, and by making it much more modular, much more reusable as well. The old dispatcher tends to have 3 or 4 classes doing roughly the same sort of thing. No, that's not happening anymore. You're going to have one action that does the work, and if it needs to be configured differently for different actions, well, that's just configuration, that's data, but the class itself is the same. That then allows us, by making the classes better, it actually allows us to have wider support, because all you need to do is put in different data, and suddenly the same code is supporting a new use case that we hadn't thought of when we were originally doing the code. The old dispatcher is quite fixed on, this is the way this use case is meant to run, I will run it this way. And it locks you into a particular mindset at times. And as we started the refactoring, we worked out, yeah, this is a large project. We are keeping some bits. We're keeping the test definitions. So the Lava test shell definition YAML files that you've got in your Git repos, we are keeping compatibility with those to support the current use cases. We are keeping the method of deployment, which is packaging on a Debian system. And that's about it. So none of the old conventions are going to survive, because they were too locked into how they were doing it in the old way. And to break them up and make them more meaningful, you're actually changing the names and changing the structures of them anyway. The way that actions are assembled into a pipeline is by doing things called strategies. So these strategies are ways of joining actions together to get you into a test. The strategies are normally determined in the new dispatcher. They're going to be determined by our code on here, but it'll be a case of you just specify labels in the submission that says I want this, 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 and this, and then the pipeline populates those along and builds the complete set of classes.
Do you want questions at the end?
Yeah,
Or do
I'll wait into questions in the middle there.
Oh, so the strategy is replace JSON, kind of? Yeah.
The strategies are a way of implementing the JSON. The strategies are based in the Python code, and we can make it more modular on that basis. But yes, the job definition is changing fundamentally. It's changing in an incompatible way. We are deliberately not retaining any kind of compatibility with your JSON job submissions. The meaning of the file, the meaning of the test has fundamentally changed. The way that the test is actually going to run is fundamentally changed.
But
you may be able to use the same files in some cases, not for using hardware packs.
So, I'm
But-
sorry. So now I can use Python basically to define my test case.
You can't load the JSON, do some Python mangling, and spit up YAML. No, because you'll need to understand what the test is doing to
Yeah.
work out what the strategy will be for the new test. Is even the so the KVM example has changed quite a bit. That's in the documentation already. Is that you can see roughly how that goes. But as we go down the road and build more of these use cases up, the more data goes into the actual submissions. And we're making this much more explicit, where we're saying, well, if you want us to deploy some media somewhere, you've got to tell us where. You've got to tell us what file system you want to put on, or do you want it as an untouched image. We're setting these things out, and if you put it out that way, it will happen that way, or the test will fail. Lava isn't going to do the work for you anymore.
Mm-hmm.
One of the main reasons for that is to make the work of the dispatcher more predictable, more reliable. It's about making the infrastructure better, so that we can pick out then, right, this is an infrastructure error, this is a test error, this is actually a coding error.
And the way we are now defining that information is in a Python file.
No, it's a YAML.
YAML file.
It's a YAML
Oh,
file.
it's YAML
It'll be
file.
YAML
Oh,
all
oh,
throughout
YAML.
now.
Oh, okay.
So
But-
we will have YAML for the job definition and for the test definition.
Oh,
It will be the
okay.
same format.
And-
And as is written on the slides, we will not provide a way to automatically transform a JSON to a YAML, because as Neil said, there was some cases where there is a gray area. People don't really know what Lava is doing. Like, is Lava rebooting the board or not? It's in JSON, it's implicit. In the new dispatcher, it will be explicit. You will have to say, I want to reboot the board now.
Mm.
Otherwise,
So-
it won't reboot.
So yeah, so it won't. So you have to look at your job definition and decide, here I'm booting, here I'm not booting. But it's not difficult, to be honest. It looks the same, like the old definition, but it's the format change, and it's completely explicit now.
The other advantage of doing YAML for job definitions, apart from, well, there's a couple of main advantages. One, it allows comments in your job submission, which is a real revelation. And then the other part to it is that we've already put in, thanks to Rémi, inline test definitions. So now you can have one file that is your job submission and your test definition in one file.
Does YAML support looping or control logic or like if, else, loops, iterations? No.
No, that'll be encoded by parameters you put into the actual YAML. But we've got explicit repeat support already, along with the failure retry and stuff like that. But you can sort of specify. So, for example, the repeat support can be repeat a single top-level action, or you can, by changing the indenting, you can indent a whole block of actions, top-level actions, and repeat the entire thing as one block. So you start the top, work through,
Can we
back to
just
top.
clarify something, that at least for a period of time, the submission JSON will actually fire up an old dispatcher?
Yeah.
Oh yeah,
Yeah.
yeah. So the refactoring is not going to happen overnight. It already hasn't happened overnight. It's already taken quite a long time. It's going to take a long time yet. That's the last slide. But it's a gradual migration that we're planning, right? And we're going to make it available. So at the moment, it's Lava developers only. It's command line only. We haven't. With next stages later on, we'll come with how we're actually going to do that. But the main thing to think about at this stage is we are dropping certain binary formats, certain image constructs, certain ways of doing things that require Linaro specific ways, or dropping images that need Linaro specific auto login support or console support and stuff like that. It will be a case of, yes, you can have all those to generate the image and give the image to Lava, but doing that work on the Lava dispatcher for every job makes the Lava less reliable. And
just again to clarify, but if you submit a JSON file with a hardware pack
Yeah.
and rootfs,
Yeah.
it will still do the Linaro media creator.
The old JSON stuff,
Okay.
all the old dispatcher, the current dispatcher is working until we get to a point where all of these use cases are covered, and then that's on a later slide. I'll cover
So that
on
answers
there.
your question earlier, Fat.
Yeah.
2015.
Yeah.
Maybe later.
Patches accepted. We'll get there
Oh.
faster.
That sounds like a version country. Better than what I heard so far.
So the scope is frankly enormous. What it gives us are completely new mechanisms of actually deploying stuff you want to test on your board. We've talked about doing more things with different kinds of media. We're getting away from the utter reliance on SD cards. So now you've got USB media, you've got SATA support. This is already in the refactoring, so you can actually boot the board with an image that's just your basic, some sort of sane image that is something you know works. Use that to deploy to what we call secondary media, USB stick, SATA drive, and then tell Lava these are the files you want to pull off those media to reboot the board, and Lava will say, right, I know the U-boot commands, I'll feed those in, and you get booting off the other media. So you effectively got two test images, one feeding off the next. We've got KExec support. We are still looking for a testable KExec device board kernel combination. The other
One which is working every time.
Yeah, we got some that work sometimes. But so third-party images. Again, this gets us away from the need to have Linaro overlays or Linaro serial console wrappers and stuff like that. Take an unchanged third-party image. The checksum will match what the third-party site offers as their checksum. When we download it onto the actual Lava job, you'll see the same checksum there. Then we put the overlay either next to it as an extension, or maybe we'll put it on top. We haven't actually worked out exactly which one will work for different devices, but you get exactly the image you expect to have. Installer testing. Now this comes in from having secondary media. It now means you can leave the SD card alone. You can have your installer going on to USB media, and you can test the installation onto SATA. This is something like a QB truck. Oh yeah, that just works. Because you've got all these different ways of deploying within one test. We've already got work going on for grub support. UEFI support is obviously an important step on that. The difficulties with those are still that we would need some kind of hardware solution for actual bootloader testing. But bootloader execution is fine, depending on the actual device. There are certain devices that need bootloader changes every single time. That's more of that may well be a problem rather than a solution. But there is support for doing all these extra mechanisms. And this is where you get into problems with refactoring. This is where we are. It'll save time in the long run, yes, yeah. Promise, it really will.
With question, taking your idea further, shouldn't even how you put the board be outside the dispatcher?
In terms of the actual boot commands
Yeah,
can
the
be
actual-
specified in the job submission. The main thing is that we need to keep the SD card or keep a Lava bootloader as sacrosanct. So there's always something to get the board back up for the next user, and not to brick the board by changing the bootloader or changing the options to such an extreme that you can't actually make the board usable for the next job. So that is the limitation that we need hardware solution for, to actually allow you to put a different bootloader. Now, if the device supports configurable bootloaders, there are devices where you can use a GPIO line or something like that, and it'll say, right, now it'll boot from that medium. Yeah, go ahead. If the device supports that, Lava will now support it as well. And you can actually say, yeah, put my UEFI hardware on that at the secondary device, and I'll boot from that. That's by toggling GPIO lines. That can be done as well.
It's probably important to mention SD doesn't have to be where the bootloader lives. It could be something else, but
SD is the traditional place, because so many Lava devices have relied on SD up until now, and then, like certain non-deals, go ahead and blow it away behind your back without telling you. So what's the comparison of the old and the new? So the old one will keep on running with JSON input and hardware packs and master images and all the other support that we know about. It'll keep on running until we get to a point where the new dispatcher is capable of supporting all of the current use cases that still need to be supported. There will be a reassessment. People will go around and think, actually, I don't need to actually migrate that job because it wasn't doing anything useful for me, or that use case has gone away, whatever else like that. Not all the jobs will necessarily migrate. But we will be doing this as a simultaneous long-term migration. We're planning how to do that by having two classes that relate to a single device. So if you're using the old style dispatcher, you'll use the existing device path through the classes. If you're using the new dispatcher, you will then go through and pick up a different device configuration which is more compatible with this.
For the exact same board, it can
Exactly
be
the
booted
same
with
board.
the old dispatcher or the new dispatcher, depending on the job.
And that will dictate whether you can submit a job to the new dispatcher, is whether that device or enough of those devices with multi-node have actually been ported to the new configurations. So that's the way that we'll be able to step through it and control it. So the old dispatcher, yes, hardware packs. New one, we're aiming much more for third-party images, untouched, exactly as they are prepared for us elsewhere. Yeah.
What's the difference between all? Because we can already do that.
We can, but there are a surprising number of requirements and hidden assumptions in how Lava deals with third-party images. They need particular console support. They need particular login support. Auto login and specifying the login user and the login password will become the default. It won't become the exception, because that's what, if you download someone's image for a QB truck, it'll have someone's password on that to document on a wiki page somewhere. You need to be able to put that in and test the image that they've given you to reproduce someone else's problems. We've already started moving towards NFS masters. Again, Arndale's were a major factor in pushing that particular movement through. But that will be, again, that will be the default way of dealing with most boards where we can. Gold standard images, that's Well, yeah.
Sorry. So what NFS master? So you mean that the lava boot?
If you boot the device without giving it any boot commands, it'll just boot into an NFS master.
Yes,
So
we-
this allows you to do things like the secondary media, where Lava will actually give you a sensible starting point, or you can define your own.
The only way to install things on a board, on the USB on the board, is to boot the board and let the board install something on the USB directly.
Most bootloaders.
So
yeah.
Lava is booting the board
But
with
not-
his own image, is asking the board to install something on the USB, and then rebooting the board, saying now you boot on using the USB device. And then you will this is only the last action that you use here. So the board booting on USB. But before it has to be booted on an SD card or now NFS to be able to do something on the media that the board is controlling.
Sure, but you're assuming that it boots first to whatever.
Yeah,
Right,
that's
in order to do
it,
this
it has
installation.
to boot on a sane image that we control. That's
Okay.
before it was always on SD card. That's why if you break the SD card, you break all the jobs that are going afterward.
Mhm.
That's why now we are trying to move to NFS, because you can't destroy NFS as easily as you can do with SD cards.
As long as you have network.
Yeah.
Yes.
Yeah.
Obviously.
Yeah.
We need network.
Yeah. But the NFS masters, one of the main uses with the new dispatcher will be, yes, a shortcut for those who don't want to have to supply their own NFS, but also it's for health checks to make sure the board is actually still responding to commands and PDU resets and stuff like that. So the health checks will be NFS.
But how do you
jobs.
control that the first boot is through the interface that you need on some boards you need some sort of hardware, external hardware control.
Then you will specify that in the actual job YAML, and that particular device won't have an NFS master. It'll actually boot. Presumably, if you just power it on, it'll either go to a prompt that is specified, or some kind of bootloader prompt or something like that. So whatever the device will go to, if you just give it power, that's going to be effectively the starting point for Lava for its own health checks, and can be adopted by other tests, or you can specify your own parameter.
Yeah, so the way that Lava master images work today, it's assumed that when you power the board on, it just boots to the master image. And so what's nice that we found about the NFS masters is that when like we want to change a kernel out in the master image because we need to add some sort of feature like SE Linux support or something like that, we don't have to ask the lab team to go and redo all the SD cards. We can simply just change a URL in the configuration, and it'll pull the new kernel in, and you can redeploy master image root file systems if you need to make a tweak to it very easily. In fact, you can do it completely remotely. You can set up an NFS master image. So you could boot the master, but then I have a Lava test shell job that will go and actually create the partitions given a block device and put the partition labels that Lava expects down on whatever block device you want. So you basically can be completely hands-off and deploy master image down.
Yeah, I understand that. But how is that different from the Linaro? I forgot the action. Linaro kernel boot or whatever it's called.
Oh, it uses basically the same
Oh,
exact
okay.
procedure. Yeah, it's just
Okay.
it basically uses
The
that
new
to strap a.
implementation with
Okay.
more power.
Yeah.
That's exactly.
And
Okay.
It uses the same stanzas and
Okay,
everything. yeah.
okay. Now we're on the same page.
So, yeah, new media support. Now, the way that the new dispatcher is being written, we're basing it on unit test driven development. So we write the design, we write the unit test, then we write the code, and then we make sure the the code passes its own test. You can follow that now. We've got a daily Lava job which is running on staging, which checks our own unit tests on that. So there's an image report that you can track how we're doing with the unit test. So we've gone from, when we started the refactoring, we had only 42 unit tests in the dispatcher. We're now at 186, and we've got loads more to do yet. I've mentioned already about overlays and versus extensions. It became apparent during the refactoring that actually the overlay is the Lava test shell scripts, if you're using them, your test definition Git repos, and anything else that Lava actually might need to install packages on that particular system based on its OS or whatever else. So there's a bunch of little helper shell scripts. Multi-node goes in there as well if you specify multi-node. that can be thought of as an overlay, but it can also be an extension to one side mounted separately.
Does it include the customized thing, customized extension, directive or whatever?
The customization action is there. We haven't defined exactly what the.
It's not the same thing as overlay. It's something else.
Yeah.
Yeah, it's planned but not done yet on the new dispatcher.
So those are the signs you'll see. Oh, we go back to gold standard images because we're just going to mention that. In order to make error identification easier and clearer, we're going to go work with the QA team to build a set of gold standard images. These are images that we will use in our own functional test inside Lava. These are images that we will refer people to when they say they've got a problem with their test image. And it's a case of these are the tests that we regularly run through, they'll be used during our development, they'll be carried on. They are another level of the unit testing that we're doing. It's the functional test inside. And we're going to make sure that we've got as wide a coverage as we can get of these gold standard images. We'll only upgrade them when we need to. Now the whole point of that is to give us this reliability back, so that we can easily reproduce someone else's test case, because we don't have to go back and try and find which snapshot were they using. Oh, that snapshot's been deleted and it's gone away, been replaced. The test should be able to work with gold standard images, and if it doesn't, we're probably going to say it's a problem with your test case rather than a problem with the test.
So, and one other thing about that too, when somebody installs Lava and they put a device up, then they try to go figure out what the image is or a job, so we'd actually be able to provide them a YAML job definition that they should copy and paste it and it'll run.
So if you're setting up your own lab, you have the ability with this model to have a little helper script that sets up everything and actually starts running devices running jobs on known supported devices from the get-go. So your job number one actually passes, because you'll just be able to say, well, yeah, we know that image works. You've told me it's that particular device. I know how that works. We can get the configuration from there, and then you can modify that configuration and move your lab onwards from there. But you've got a known starting point.
Yeah, interesting. What is the refab images using Tor? You got all the.
Yes. So the other things that have been taken out, sync. We had many problems with sync.
The sync command.
The sync physical. Now, how many people here have typed sync after writing to a USB stick or something? Yeah.
And again.
Once you start doing anything on a system that has more than one user, more than one file system, you do not use sync. Look at what sync is actually described as doing. It's a syscall that flushes the kernel file system buffers. All buffers, local, remote, it doesn't make any odds. And the kernel will sit there and block until it has. And then you get a multi-user come along and say, oh, I need a sync as well. I need a sync. We had Lava dispatchers sitting there in sync stall for 12 hours. And it's a syscall, you cannot kill it. Kill line doesn't work. The only solution is to reboot the dispatcher, at which point all your jobs are gone. So sync is bad in a multi-user environment, but we don't use it. The other thing which we're dropping is this last bit about ripping up images. This comes in with Android. A lot of the Android build systems will build you an image, but then Lava comes along and says, well, okay, I need that bit over there, that bit over there, that bit over there, that bit in that file system. I'll change that file system over there to that one over there. And then I'll munge them all onto 5 different partitions on the SD card. There are use cases where a particular Android device will have a separate physical device for the SD card, the user data, the system data, whatever. That's fine, we can support that. The problems come when you've got SE Linux support inside one of these images, and suddenly you've got to replicate that inside. Now means you've got to have SE Linux inside the kernel of the master image of the device, which now affects everybody using that device. And you're going, that's insane. So we're moving away from that. That's another reason to go for using untouched images. not changing the image, because if there's partition stuff and file system attributes, and maybe someone comes up with another brand new file system, maybe Btrfs is improved and another one, and they give us an image which uses that file system. Well, their kernel understands it. No other kernel is going to understand it, so we couldn't rip that image up. We would have to say, sorry, you can't test that image. With the new dispatcher, you can. Under the hood, what are the changes? Very big one here that causes a lot of reliability problems within the existing current dispatcher. The current dispatcher has a persistent Postgres connection, read-write, from every dispatcher to the server. And if anything interrupts that connection, you get bugs. We're not keeping that anyway. Every dispatcher also has a completely unused Postgres database. That's not going to happen. The salt config is going away. The actual device configuration is going to move into a single place. You're not going to have 7 dispatchers with 7 different device configurations.
You're trying to put me out of a job.
Trying to make your job easier.
That's the goal. That's all the goal of it.
The device configuration lives in the database. One configuration, one database. Yay!
Bloody right.
Finally, yes, I think
This
we
is
can all
what
finally.
this is what we've been calling inside the team the dumb dispatcher model for some time, and we're finally able to deliver it because of the refactoring. This is going to be a major, major win. Now, it allows us to make no assumptions about the dispatcher. We can actually step back and say, well, okay, all the server's going to do is use all the data that the server has got, build this set of data, throw it at the dispatcher, and the dispatcher just goes, all right, I'll do as I'm told. I'm not going to second guess. I'm not going to say, oh, sorry, I haven't got that device, when the database clearly says it has. It's going to just do as it's told. So, I've got XML RPC on there. That was an initial stage. We are looking at other technologies to replace the communication between the dispatcher and the server. Rémi, you've done some ideas on.
Yeah, I'm looking at 0MQ for the people knowing 0MQ to replace the connection between the dispatchers and the server. Even so first thing for sending the jobs from the server to the dispatchers, first thing. And the second one, even maybe to send back the logs from the dispatcher to the server, because for the moment there is an SSH-FS connection between each dispatcher to the server, read-write, same issue, which if it breaks everything. So using a more classical socket may be a good option. So we are looking at that kind of features.
We're keeping what Lara's good at, which is the actual scheduling and the dispatchment thing, and we're throwing out the things that other packages, other tools do better, and using those tools and looking at and proving which ones are the best ones for our use case, rather than just inventing something because we happen to be within Lara. Again, this whole model allows us to fail early with information about why we failed, that is reliable information. We can actually, we've already got the hooks in there so that particular forms of failure will trigger a diagnostic action that goes off and gives you debug information. This could just be the routing table or something. But these are definable.
This reduced bundle data, right?
Yeah.
Are we talking about the data which we are sending from dispatcher to scheduler?
By reduced bundle data there, what I mean is the earlier thing I mentioned, which is that the current dispatcher decides what data you're going to get from the test itself and doesn't tell you what other information you might have had. There is a set of code in the current dispatcher which bundles up what it thinks are the results and only gives you that data. And the rest of the data is left on the partition for the next job to wipe. So there is a terrible data loss issue there. So what the new pipeline is doing is recording everything as it goes along. It's storing all the results it can, everything it thinks is useful, and if you need more, we can put bug fixes in to get more information in. But it's storing it as you go along. That also means if the test falls over halfway through, you still get the result. Even if the board just completely crashes, kernel panic, gone, needs a power reset, you've still got the actual the results of the jobs so far, because they're already been sent off to the server in the pipeline. Every single time, every time we do something, it's already piped into the results. So we're building the results as you go, rather than building everything at the end, which is a very risky strategy. But that's what the current dispatcher does. The log viewing, I sort of hinted earlier, we'll be able to fold the logs, and you can specify which bits of the logs you're actually interested in. Now, we haven't worked out exactly how this might happen, but for example, you might be able to have settings in your profile within Lava that says, I'm never interested in this particular action. I always want that folded. I always want to see the kernel boot, or I always want to see this bit. So that will be your default folding structure when you look at the log. So a little bit of an idea of what the pipeline looks at. You'll have deploy, boot, and test in your YAML submission, and there'll be lots of data hanging off each of those. And as you can see there, there'll be you can have test, 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 or boot, test, test, whatever combination you want. And then the pipeline, through the strategy, builds that out into what? I need this, this, and this. All these steps are done at the validation stage, so they are done before the job is accepted for submission. And there'll also be a support for throwing that YAML submission and getting the full pipeline back as YAML. So you can see exactly what actions are going to run before it goes as far as actually getting into Llama in the first place.
The principle about why do we want to validate the pipeline before running the job, because the other option is just to run the job, and when it fails, it's failing because a resource is missing, it's failing at that time.
Yeah.
The goal is to report as soon as possible to the user that the job will not finish because we're missing something. So people will not wait for 2 hours for the job to fail at the end because one resource is missing at the end. So we're validating everything, that all resources are available, and then when everything is okay, we say, okay, now we can boot, we can begin the job. So if something is missing, you will know it immediately.
Yeah. The job isn't even scheduled if it fails validation. You will get a submission error that tells you you've got this bit wrong. It could be something simple like a typo in a URL that says that that image just doesn't exist, or that git repo has moved, it's not there anymore.
So what happens if we have a long queue on the device side? So I submit a job, and you validate the job at the submission, right?
Yeah.
Yeah.
And
It's validated again before it runs.
Okay.
At which point you'll have a test
so
error.
like you validate that URL is valid, so with the image, for example, and then I wait for 2 days because there's no queue.
And the snapshot's gone away.
And it's wiped from the snapshot. So
yeah. So the current implementation is only on the actual Lava dispatcher command line, and it will validate the pipeline before it tries to start to run the job. Now, exactly how we do that in the server integration side is we're going to sort out in the future. But yes, there will be a validation step upon or before submission, before scheduling, and there could also be one immediately before the job actually tries to start. Okay.
no.
Right, what have we done so far? It's a big job. So we've got single node, RAM disk, NFS, SATA, USB media, that's all working. We can boot from U-boot, we can use TFTP, we can do KVM boots, and we've got all those devices currently running with the new dispatcher, with those particular deployments. Notable omissions from that so far are things like Android and fast models and Junos and Yeah. I'll get to those some point. Next stage is multi-node is in review currently. It is working. I've got it running in my home lab at the moment. It's running 4 Panda multi-node jobs an hour and just spooling my mail directory every few minutes. So I'll get back to a few thousand emails on that. VM groups. We're working closely with the virtualization team to define exactly what VM groups actually need to be. There's a lot of changes going into that. We're going to have very detailed support on making sure that we only protect the essential parts of the Lava infrastructure. So we protect the Lava dispatcher. If you want to run a command on Lava dispatcher, you'll have to allow Lava to specify what command that is, because that's under our control. We protect the bootloader, the one that Lava is actually going to use if you don't trouble any GPIO lines. We protect that because we need to make sure the board is available for the next user. Everything else is fair game. Once you're in a test image with a new dispatcher, all bets are off. Everything on that board is up to you to specify and to change and do. If you manage to actually scrabble all over the SD card, then you will get a very nasty email from Dave. And your submission rights may well be removed. But other than that, if you want to run a local build of QEMU to test your virtualization and then put debugging breakpoints into it and get the output coming on 4 different jobs, that's fine. That can all be supported. The other really big area that has to be covered is Android. And the big game there is to use the images as is without any changes, and to work out how to support the actual ADB calls. So we've got some ideas on, based on how the multi-node work is already going, which is that there is a fundamental difference between a connection, which is basically something you can type at, and a protocol, which is something with an ABI. So ADB is a protocol, ADB shell is a connection. And by separating those out and saying actually you're going to be able to do that support and that support, and then defining what you can actually do to implement those actions, I'm hoping you can get that working for Android.
Did you consider USB only devices?
We are definitely considering USB connections, yes. So anything that we can actually get any actual control over the device using a particular connection will be sufficient for Lava. We just need to be able to connect to the device. If that means that we actually just use a USB connection to the device, that is clearly something we want to be able to support, and it is a definite use case for the new dispatcher that we are going to make sure is there, because it opens the door to production hardware.
Yeah, exactly. So and it's now what we have problem with is the multi-node with USB devices. So this is also going to be solved by this connection protocol.
Yeah, because if you haven't got a POSIX shell on the other end of your connection to your board, then currently you can't use multi-node. What we've done already in the patches that are in review for multi-node is we've taken the multi-node API outside Lava Test Shell. The API is now callable outside in ordinary actions. So you can specify at this point in the pipeline, I want to call a Lava sync. It could be when the boot command starts. It could be when the deploy command is finished. It'll actually come down and say, right, at that point, I need to call Lava sync. And because the protocol is built within the dispatcher anyway, it's built within the Python code, the shell scripts are just an extension that allow it to be called from there. All the code has always been inside the dispatcher. It's now available to you to actually specify it inside the actions, outside the test shell.
Well, I think that the problem with ADB over USB is that there is no Ethernet. At the moment, Ethernet is a requirement for multi-node, right?
dispatcher will not need internet on the device. It will just need it will always need the dispatcher to be able to see the coordinator, but it will not actually need the internet connectivity on the device. Because the synchronization happens through the dispatcher.
So if I have like in the terms what I'm using now, I have a VM that's running some sort of host side,
Yeah.
and then I have a USB only device that I connect ADB over USB. Will I be able to connect from the VM to the target device?
You'll be
with
able.
ADB.
You'll be able to send messages through the protocol. I'm not sure whether you'd actually have the ability to send any or make a connection outside of that, but you would be able to send through the multi-node API.
No, that's
But we'll
probably not enough.
talk about that. We'll see what else we can do there.
And that's the CTS problem for
Yeah.
those devices.
Yeah. So beyond multi-node, this is where the Lava team need to do a lot more work. We are planning a sprint to resolve all these problems. But basically the big stages are, or some big stages are yet to come. Rémi has written some templates to support overriding the device configuration. The actual device configuration data then lives in the database, and the YAML that goes to the dispatcher is generated from a combination of the database and the job submission based on templates. So you don't see the templates. It's just a case of there's data that Dave needs to put in as to which PDU port is this on, which serial port is this on, and what commands do we actually allow people to submit to this device, and then you control the parameters coming in.
So that information will be now in the
database, in the
Okay.
database and on the front end. And
Well-
bits of it will be exposed through the UI, but certain parts of it will be hidden away. So the server integration then means that we
Quick question, and you still have to go through the server admin interface to define a new dispatcher, a new device?
yeah.
Yeah. And only on the admin interface. You don't have any more to connect to the dispatcher to add one file in etc lava dispatcher devices.
Yeah,
blah, blah,
before
blah.
you had to do it in two
Yeah,
places.
Yeah,
you have to
that's
do
one.
only
That's
only in
one.
the master database. That's all.
So those are the hard bits we've still got left to do. The server integration, the scheduler support for one device with 2 data classes, and allowing and removing the Postgres. Part of our problem. We have gone through a lot of iterations with this. We've gone through a lot of things that didn't work before we got to the point where we actually got a pipeline that works. And the biggest question of all is when.
Damn, I'm sure that was going to be my question.
Yeah. I knew that was going to be the question, so I'll put that on the last slide. Not soon. There's a lot of work still to do. There's a lot of work that's been done, and there's some work which you can actually see and test and look at yourselves. But
Quick
most
question.
of it is developer only.
Oh, so but is it, like you mentioned, it's working on BeagleBone Black, right?
BeagleBone Black,
Yeah.
Panda, QB-Truck, but it's all command line stuff, and
Sure.
the issue is that none of the APIs are actually fully stable yet. And you might have a job that works with one build, and then Rémi or I put in a patch, and suddenly it doesn't work anymore. That's not going to be a bug. We're not going to have we fix that. If you're running the refactoring command line stuff on your own risk, it is at your own risk. If it breaks, sorry, we're not finished with it yet.
So if I do a git clone of Lava Dispatcher, I don't get this code.
You do.
I do.
Oh,
Yes.
Yeah.
It's already it's
Oh,
everywhere.
It's already
yeah.
installed
It's-
on all the
Yeah,
dispatcher.
you guys didn't even know that. We put that extra code in there. So
It's,
there's
it's in
the switches the
it's in a
YAML definition.
subdirectory.
It's
So
what?
it's self-contained in a subdirectory of
Oh.
the Lava
Called
dispatcher
pipeline.
code.
Pipeline.
Right?
All pipe.
And so when you submit, you invoke the dispatcher with Lava Dispatch in the same way you would with JSON, but instead you pass a YAML definition in, and then the dispatcher knows to invoke the pipeline
Okay.
in the new code.
But the sources are in a subdirectory called pipeline?
Yeah.
Yeah, Lava
Okay.
dispatcher
So if
slash
I go
pipeline.
there,
You
it's
can take
the
a look at
new
everything.
thing.
You can have a look at
Okay.
the new tree and the new code base.
And it's already in all packages that we're releasing. It's already
Ah.
inside. It just, you cannot activate it from the server interface. You need to access from the command line.
Oh, okay, only command.
Yeah.
Okay, I
Only
see.
command.
Yeah, because I
Yes.
was going to ask. Okay, now I
Yeah,
have to
you
go
can't.
to. Okay, okay.
You can't that way.
And the other big step we've got to do is with the Lava Lab to convert all devices to support both. One device at a time, going through saying, right, what can this device support? What can this device support? Well, yes, it's getting another Panda, but actually this Panda has got a USB stick, right? That has to go in the database.
Will we be able to tell, will there be a way for us to tell from sort of top level that a particular device type has not run a JSON job for 4
Yes.
weeks?
Yes.
Right. That would be
So
very
much
useful.
is changing in the server integration stuff. One of the big things we're putting in here is the pipeline declares exactly what media it's using all the way through. So then the front end can say, this was an NFS job, this was a Randis job, reliably, without having to look into the description or go into the job definition, then down to the YAML, then down to, you can actually pick it out and say, yes, this booted NFS, this boot was Randisk, and this boot was USB, and this boot was SATA. That information can now be put up into the tables we've already got. So that kind of thing will be obvious, because you'll be able to see, well, clearly that's a new dispatcher job, because it's declaring all these bits.
Hey, good timing.